Hey everybody, Mr. Covey here, your favorite pre-calculus accelerated teacher, and today we're going to talk about half angle formulas, okay? Before we start, trying to get this video to blow up. I want it to get 100,000 views in the next 48 hours, so if you could please encourage your friends to learn about half angle identities. All right, so we're going to start by just quickly going over the sum and difference and double angle identities that you learned the last few classes, okay? So remember, those formulas will be given to you, but I want you to use those to try and evaluate these three things, and we'll go through that together. So if I look at this first one, I'm doing the sine of 75 degrees. I'm thinking, it's not on my unit circle. 75 degrees is not on my unit circle, but it's the sum of two things on my unit circle. So 45 degrees is on my unit circle, 30 degrees is on my unit circle. I'm going to write it like that because then I can use my sum formula. So I'm going to grab my pink sheet. I'm going to go, oh, I can split it up like this and use my sine sum identity. Okay, so I'm just grabbing this from that pink sheet. Sine of the first angle times sine of the second angle. Oops, I wrote that down wrong. Cosine of the second angle. Cosine of the first angle. Sine of the second angle. Let me go ahead and evaluate these. Okay. So root 2 over 2, root 3 over 2, root 2 over 2, 1/2. You guys know how to do this. You can practice this on your homework. Push it all together. We're going to get root 6 plus root 2, and both of those, that whole thing is over 4. And that's our answer here. Okay. Similarly for the second one, you're like, oh, pi 12ths. Well, that's not on my unit circle. My unit circle is in radians, sixths, thirds, halves, fourths. It doesn't have 12. But 1/12 can be written as a third minus a fourth. If you're struggling to come up with that, think about it like, oh, well, 1 pi 12 is the same as 4 minus 3 pi 12. The reason I chose 4 and 3 is because when you simplify those fractions, 4 pi 12 is pi thirds. 3 pi 12 is pi fourth. And look, I wrote pi 12 as the difference between two angles on my unit circle. Go ahead and finish up this problem, pause the video, and then unpause to check your answer. All right, so if you use your cosine difference formula, you should end up getting out this in the blue box there. Okay. So that was the stuff we've been doing the last few classes. I hope you guys are feeling kind of good about that. I'm going to erase all of this stuff. And this last one, let's do this one together. So same idea. All right, well, pi eighths aren't on my unit circle, but maybe that's the sum or the difference of two things on my unit circle. So let's try some stuff. Well, I'm going to use that little strategy, like 1/8 I can split up into, like, I don't know, 3/8 minus 2/8. So maybe I can do it that way. That's cool because 2 pi eighths is pi fourths, but 3 pi eighths doesn't simplify to something on my unit circle, so that doesn't work. Maybe I can do like pi fourths minus pi thirds, but no, that's that. Maybe like pi halves minus pi thirds. Well, pi halves minus pi thirds, if I get a common denominator, no, it's just going to be pi 6. We're going to do a problem here that we can't overcome. The problem is pi eighths is not the sum or the difference of two angles on the unit circle. So I can't use those strategies that we've been using for the other problems. It simply can't be done. Okay? But I know what you're thinking. You're like, pi eighths isn't just a random angle. It actually is connected to the unit circle. And the way it's connected is pi eighths is, sorry about that, people being loud in the hallway. Pi eighths is half of an angle on the unit circle. Okay, now we don't have a half angle formula yet, but that's what I'm going to show you right now. So the nice thing about pi eighths is it's half of pi fourths. Okay, so that's the idea we're kind of going to use here. If you're thinking, can I just use my double angle formula? Well, wait, be careful here. Pi ace isn't double an angle on the unit circle. It's half an angle. So that's a different formula. So these are different than the double angle formulas. These are the half angle formulas. Okay. Here are your three. There's one for sine, one for cosine, one for tangent. There's something really important to note that's different than the sum or difference or double angles, and that's this plus minus for the sine or cosine. Obviously, the sign of an angle isn't positive and negative. That's not what the plus minus means. It's either positive or negative, and you have to use what you know about trig to figure out whether you want the positive or the negative version. And I'll show you an example of that real quick. All right? Cool. So here's the idea. Trying to find the cosine of 7 pi eighths. It's not on my unit circle. I know that. It's not sixths, fourths, thirds, halves. It's not on my unit circle. But, it also can't be written as the sum or difference of two angles on the unit circle. You'll start to learn that eighths can't be written as sums or differences. But it's half of an angle on my unit circle. 7 eighths is half of what? 7 fourths. So it's half of 7 pi fourths. Sweet. So to find the cosine of 7 pi eighths, I'm going to grab my cosine half angle formula. Again, these are on your pink sheet. You do not have to have these memorized. Now, the thing you're doing the cosine of is the angle that is on the unit circle, obviously. Otherwise, you wouldn't be able to do it. So notice that right here, I put 7 pi fourths. That's the angle I know. So I'm finding the cosine of half of it using that I know the cosine of 7 pi fourths. Okay, let's calculate this out. We're going to come back to this plus or minus issue at the end. So I'm going to calculate this out. Cosine of 7 pi fourths, beep bop boop bop, root 2 over 2. So I'm going to get 1 plus root 2 over 2 over 2, all underneath the square root. I want to clean this up a little bit. I'm going to do a little rubber banding. Get 1/2 plus root 2 over 4. Giant square root. And it'd be nice to put these back together. So I was just trying to deal with that weirdness. So I could write this as 2 plus root 2 over 4. And if you really want to do some nice cleaning up here, I'm square rooting a fraction. I can square root the top, which doesn't clean up. But the bottom, I actually know the square root of 4 is just 2. So this is the fully cleaned up version. Now we got to talk about the plus or minus thing, which gets a little confusing. Okay? All we're trying to decide is, should the cosine of 7 pi eighths be positive or negative? Again, 7 pi eighths is not on the unit circle, but we know where it is roughly. Okay, let's just draw a little picture here. Well, 7 pi eighths is going to be less than pi, but just a little bit less than pi. Okay, so it's going to be like somewhere over here. Is the cosine of that angle positive or negative? Well, the x value is negative, so it's going to be negative. So I'm going to toss a negative out there, and that's my answer. Okay. All right, let's do one more example here. This is the other kind of example like we've been doing for the sum and difference in the half angle, which is, oh, they tell me about this angle. Not on the unit circle. Okay, so they're just telling me the sine of this angle is negative 8 over 17. They're giving me a hint about where to draw this angle, and they're asking me for the cosine of half that angle. Okay, so I'm going to draw a picture. This is telling me third quadrant. So I'm going to draw an angle in the third quadrant. I'm going to draw my little reference triangle and make the opposite over the hypotenuse, negative 8/17. I'm going to do a little Pythagorean theorem, or I'm just going to remember my triples to figure out that this is 50, 8, 15, 17. Or you can do Pythagorean theorem. I got this triangle, trying to find the cosine of beta over 2. I'm going to grab my cosine half angle formula. Again, this will be given to you. And I'm going to come back to the plus or minus. Don't forget about it. All right, well, now that I have this picture, I can figure out the cosine of this angle. Here's my reference angle. What's the cosine? Adjacent over hypotenuse, negative 15 over 17. Cool. Let's draw a little line over here. So my cosine is going to be giant square root 1 plus adjacent over hypotenuse over 2. I'm going to clean this up a little bit. 1/2 minus 15 over 34. And I'm just doing arithmetic here to clean it up. Get a common denominator of 34. I'm going to get 2 over 34. It'd really be nice to split this up. This is all just kind of annoying arithmetic. But if I split it up, I need to rationalize the denominator. All right. A lot of kind of like simplifying, cleaning up here. On the top, I get square root of 68. On the bottom, I just have 34. And that's my cosine. Don't forget about the plus or minus, though. And maybe you should even do it at the beginning. Here we have our picture of theta. Be careful. This picture is of theta. It's asking me about the cosine of half of theta. So this is where you really have to be careful. Pay attention right now. Here's theta. I'm trying to figure out whether the cosine of half that's positive or negative. I should try and estimate where half that angle is going to be. So this angle is like, I don't know, 200 degrees. So half of that is going to be like 100. So half of that is going to be here. Okay? So don't make the mistake of thinking that we're talking about the blue angle. We're not. We're talking about half that angle, which is this yellow angle. So then I have to think about, hey, for this yellow angle, is the cosine positive or negative? Oh, well, the x-coordinate's negative, so my cosine is negative. Okay? So toss a little negative down. And we're done. But figuring out whether to use the positive or negative is going to be kind of the tricky part. All right. Cool. That concludes this video. That's it.